All right. Good afternoon, everybody. I am still fighting the remnants of this cold, and I'm getting very tired of it. But, I had 2 weeks of vacation, including today, and I'm like, I'm not just going to sit around and do nothing. I got to do something today. So I'm going to keep trying to get past this part 2 of day 11, and then hopefully make some more progress on other parts of Random.Code. So we know what we've been dealing with, and I've tried some things with like pre-compute maps and looking at this. This is turning into like one. It's not hard in the sense of I know how to do it. It's just one of those. There's definitely a trick to it, or at least some things you have to be really cognizant of and notice, so that you don't spend forever trying to calculate everything. So somebody gave me a hint that said if you start with just 0, there are 54 different kinds of stones. This was on Blue Sky. After 22 blanks, these are the same after 23, 24, 50, or 60. So what I'm looking at is if I start with 0 and I broke it out, you can see that you start getting, if I highlight 0, as a single 0, you'll see it after the first, second, third, fourth. Actually, let's put a space here so we grab those. Well, that doesn't really help. But, you see that we get 1, 2, 3, 4, and then we see it 5, 6, 7, 8. Do you see it in 9? Not 9, but 10. And then, so the number of zeros, individual zeros that show up, start getting to be more and more as you go down. And this is important because as you start generating these, you can start to go, hey, once I calculate 0 for 75, which the way that I'm calculating it is I always go, well, if I just create one stone, then get the stone count for the next iteration. And then if I break it out, I get the left one and then the left one and then the left one and so on. So I only go down 75 stones, and then I start to wiggle my way back up, so to speak. And the reasoning that I have is 0 seems to be very, not cyclical, but it starts showing up a lot. And so if you can start getting the values of, hey, I know what 0 will be at this iteration. If I have to do it for this many iterations, I know what the count's going to be once I calculate it. And so once I do it for one of them at different iteration lengths, and I start, mapping for a given number of a particular set of, iteration count, this is what the count will be for that number. Okay. And that may not be the whole solution. I may still be taking forever to try to figure this out. But the thing that, again, to notice is once I calculate like 4 here, I can look up the value for 4, for 4, for 4. I don't have to keep doing those all the time. And I think that's what was really killing my search before. So we basically want to map 0 to 9 with their iterations and their counts and some other values, and basically anything from that 54 set that person gave me a hint on. And what did I do here? Oh, I just took some random number and I was basically playing with it and saying, hey, once you get a number that is a power of 2 digits, that's going to decompose down into these constituent parts here. Okay. And also if you have an even that splits an odd, but it becomes an even set of numbers, power of 2. Anytime you get a power of 2, those are going to rapidly ramp down to just those single digits. And so if you can get those single digit ones, those really, really help, and it seems like that's just basically what happens. So the other thing is, and this I noticed right away, but it didn't really click with me too much until I started doing more of this analysis, is even though the problem says like the stone positions never change, they don't matter to each other. So you can you can resort or put the order of the stones in any order you want, because getting the count for this would be the same as if I reverse this. It doesn't matter. And so what I'm thinking is we start and we get the one for 0, and then we get 1, and then we get 2, and then we get this one, because this one will decompose rather rapidly. And then hopefully we can start to get some progress rather quickly with these 4. And then these 4 that are remaining, we should be able to calculate, hopefully, quote unquote, rather quickly. So what I want to do is I want to basically say, I want to reintroduce a method that says get the number of stones for a particular value with a particular set of iterations, but give me back a list, because I want to see this 54 set with 0 after 25. And I'm not saying it's just 54. There may be more in there, but there are at least 54 unique ones. And that's what I want to use to say, those are the ones that we want to capture when we're getting the stone count for a particular iteration value. And then we're going to use one pre-compute map. And it's going to, I said concurrent dictionary here. I probably will just make it a dictionary, and I'm probably going to just keep doing this. Well, maybe I do. I'm not sure. I'm wondering if sticking with having this be single task, not multiple tasks, even though multiple tasks may give, it's something we can play with, but I think if we keep it to a single task, try it, and then we can try multiple tasks and see if we're sharing a dictionary, if that would actually help any at all. I'm not sure. So I'm also considering making the increments incremental rather than I start at say 75 and I go down by 1. It doesn't really matter, but I think it helps in terms of the direction I'm going in and what I'm looking for. I think it just, in my head, would make more sense to say, yes, we're at, we're going incrementally. So let's change this around to dictionary and remove task parallel processing for now. And then consider reintroducing tasks and change to a concurrent dictionary of big integer int big integer. The key is the stone value and the number of iterations that you want to do with it, and then this is the value that you find. Okay, let me get some music going. Turn that down. And I was also thinking right before I started the stream of I might make this a separate type in and of itself, so I can say here's a stone number, here's the number of iterations, and then that way I can have it just be all encapsulated in one object. It's not a big deal, but so let's get to it. Close that out. That was to help somebody out with some issues. So let's get back up here and let's grab what we think might be a more optimized order to move in. We have a set of tests here, which is good because as I start to change things around, I'm going to want to do that. Let's have a public sealed type class. It's been a while since I coded. By that I mean a couple days. Stone list generator. Okay, so what we want is a public immutable array of big integer stones. And that'll be a get. we also want to say here, public int iterations. Now in this case, we're not going to use a map. We simply are going to generate it the hard way. Basically the way I had been doing it. So I want to say var stones is equal to a new list of those. And once I get done with everything, I'm going to say this dot stones is equal to stones to immutable array. So I want to say for var I is equal to 0 as I plus plus. That's the number of iterations we're going to do. And then we want to say for var j is stones.count minus 1. Yep. All right, so here we basically do our algorithm here. If stone, sorry, var stone well, we have a stone up here, and we want to put it in it. So we want to save our iteration stone, because I can't think of a better name. If iterations, if it's a big 0, then stones at j is equal to a 1, right? And then we do this crazy stuff. Else. We say iteration stone digits. Of that. If this is even, we don't care about that. We split it into 2 spots. We say that's right, we say stones at j can be the quotient, so that replaces it, but now we need to insert at stones, insert at j the remainder. Okay. Else we say stones at j right. Yeah, because if it's an odd number of digits, you multiply it by that. So you take whatever the stone is there. Yes. There. And so we can use stone list generator to say on the program here, our list generator is equal to new stone list generator. We want to do 0. And let's just do 7 for now. And then console write line. I don't think this is going to give us what we're looking for. Yeah, because that's just gonna string.join. There, it's all better. Oh, that ain't good. Why is it giving us just that? I'm probably just missing something simple here. So we have a stone with just 0. 7 iterations. We're going to go through. That should be 0. We're going to say stones J. And we should skip out. Okay. Now we go through and we've got still 1 stone. It's not 0. Oh. We should never be referencing this after. There should be only 1 spot. Yeah, let's run it now. So is that what we have after 7? 1. So this is 1, 2, 3, 4, 5, 6, 7. It is, it's just the other order, but that doesn't matter. It's 9088, 404, 24, 28, 404. Yeah, okay. So let's see how long this takes after 22. Pretty quick, which is kind of what we expected. It's just getting after that's the problem. So unique stone list is equal to new sorted hash. Isn't there a sorted hash set? No, there isn't. I thought there was. Why would I want to do that? Well, I don't really care about performance for what I'm trying to do here. Yeah, so we can and then we can print out this. Let's see what we get. Oh, would you look at that? What's the count? $54. So these are the 54 values. Those are the ones that we want to be celebrating, so to speak. Okay, so now we want a class that kind of does the same thing. Except what we want to do is say it's a stone count generator. So we're given a stone. Just have to think here for a second. That's what we want, is the count. And we also want in here, from my notes, thank you. Yep, we haven't used it yet. We'll get there. So we basically want to say this. We don't care about the iterations. What we do want to say, though, is if this stuff... Oh. Okay, so... Wait, if we get down to 1, we just return 1 through 1. This dot iterations, this dot count is equal to iterations, this dot get stone count for stone and iterations. Now, the thing we got to add here is if what we want to say is I think a triad, right? Does that return a false if it basically existed? So what we want to do is say but for iterations minus 1. So we get the value, we add it to the map, and we return. Same thing here. I mean, we could technically do the same thing here too as well. We could say, we could add this for one iteration would give you 1. So in other words, if you give a 0, right, iteration 1 iteration gives you 1. I think that's the way to look at this. Same thing here. We'll give you 2. This gives you 1. What we want now is var quotient count, var remainder count, return quotient count plus. And so now we take this. No. The quotient saying this is what its count was. And the remainder, this is what its count was. And then we add the two together. Except we only want to add it if it's in this list. Private, read-only, immutable, array of big integers, targets, equals yep, that'll work. And now what we can do is we can take this, except that's totally wrong. So we can say in that, wherever you find a space, no, I said current document. I want selection. If you find a space, make it a comma space. There. And now to make this a little bit easier to read, we can kind of break this out a bit. Now this is a case that we know we want to try to add it because we know that this is one of them. Okay. If this.targets contains the stone, then we try to map. Okay. Otherwise we won't. We just return the value. So we need to do it around all these. So if we do the quotient and the remainder, then we'll try to add it. Otherwise, we're not going to put the number in there because it's going to take too much. Okay. So now, I don't know how much help these are going to be. I'm kind of like, should I keep these around? I'm not sure. Let's take out the tasks. Let's put the stone count back up here. And let's say stone count plus equals get stone count for that. Don't have to wait for tasks anymore. We don't have to do that anymore. We just return that. Except what we want to do here now, well, let's make sure that still passes all of our tests. Does. Okay, good. Now let's change it to being stone count plus equals new stone count generator of the stone and iterations. Count. What does that do? That was much quicker, but of course that's subjective because that's what I'm doing right now. I mean, okay, what does 45 do? That was pretty quick. What about 50? That was pretty quick. That was pretty quick. That's highly encouraging. Yes. Booyah. Doesn't it feel good? Doesn't it feel good when you finally get an answer and you're like, oh, that feels so good. And actually, you know what I just realized? I'm not doing it right. I mean, I am doing it right because part 2 of day 11 is complete. Oh, it's such a good feeling, the endorphin rush. Let it flow. But I just realized something. I wasn't doing it right. Because each stone is getting its new generator. I'm not keeping the previous map of discovered values, and I should do that. In other words, let's add on a so we want to say pre-computes here, and we also want to say pre-computes. And we want to say this stuff let's change this. Let's say And actually, yeah, so now, yes, all this is garbage. Maybe more ways than one, but oh God, did I put it on the wrong one? Okay, so now you can start it with the number, but then once you want to generate another one, if you've done pre-computes before, what you can do is if we come up here, we can say pre-computes and then we can do, wait, let's get this. Var generator is equal to that. And then we'll do this, but in the interim, yeah, so now oh, we put that at the end because of reasons. There. It's hard to tell if that really made a difference. But what we can see now is if we put this, we're in debug mode, right? Yeah, so let's clear out all of our breakpoints. Nope, we got to run it in debug mode. So right now we have 0 in it. If I do F10, that doesn't make any sense. Oh, wait a minute. Yeah, we're doing 25 iterations, but we should still have gotten... Wait, something isn't jiving here. I mean, it's giving the right value, right? Yeah. Should put that in our answers list. Well, why isn't it? That is weird. You know what? Let's get rid of this. Yeah, and then let's get rid of that. So this should be 0. Oh, now we're getting into... I'm kind of confusing myself here. This step pre-computes. Let's make absolutely sure. Okay, now we get 485, which makes sense. So now we've got 485. So you can see in here we get like, we scroll down a little bit. Yeah, we know that, and I'm sure I could do a whole bunch of analysis on this. But this is just for 0 to get to, you can see like 19 there. But now we're going to increment our stone count, right? Why did you jump back up here? Oh, that's for the 75. Okay. So we say each stone. So we still got 0 here. Now we go through. We got 2,485, which makes sense. We do it again, and now we've got 2,006. So we're adding on a little bit more knowledge. And now I've got 264. 27. So it increments, like it gets a lot, and then it's a little bit less with each one. That one got 42, so that did increase it. So let's put this back to release mode. I'm just playing here for a little bit until I get this to be what I want, you know. What happens if we just go a little bonkers here? Let's do 100. Well, 100 gets a little bit too much. But it did it. It took about, excuse me, about 5-ish seconds. But we got a value. You know, and that's all we're looking for, is we got a value. So we have finally conquered day 11. What a good feeling. All right. I'm sure there's still like one optimization I can make now is make this tasks, but then I would have to have a way to say share the concurrent dictionary and make sure that reference is the same across all tasks so that they all get the same map pre-compute dictionary. But yeah, that went fast. That went so much faster than what I was doing before. So, Prost. All right. I'm going to refill my coffee here, but I can do it directly here because I brought some extra. By the way, if you're new to the channel, please subscribe. I would greatly appreciate it if you haven't done that already. Slowly but surely trying to get to that magical 1,000 marker. That's the first milestone I'm trying to hit. So, making slow but steady progress to that. All right, let's move on now to problem day 12. Gulp. And finally close all that out. Great message. Minor tweaks. Okay, so that is our calendar now. 12 garden groups. Why not search for the chief historian near the gardener and his massive farm? There's plenty of food, so the historians grab something to eat while they search. You're about to settle near a complex arrangement of garden plots when some elves ask if you can lend a hand. They like to set up fences around each region of garden plots, but they can't figure out how much fence they need to order or how much it will cost. They hand you a map of the garden plots. Each garden plot grows only a single type of plant. It is indicated by a letter on your map. When multiple garden plots are growing the same type of plant and are touching horizontally or vertically, they form a region. For example, I'm not going to read on. 1, 2, 4. Oh, I guess the D is considered unique. Okay, so that would be 5. In order to accurately calculate the cost of the fence around a single region, you need to know that region's area and perimeter. Are we talking geometric area or geometric perimeters? I never liked geometry growing up. I mean, I didn't mind it, but there was something about geometry and lines and angles and stuff. It's like, yeah, it's necessary, but it was just something that really didn't like grab my interest. I've always liked like combinatorials and integers and sequences and stuff like that. I don't know why. That's what I've always gravitated to. But anyway, let's see how they define these. The area of a region is simply the number of garden plots the region contains. The above maps type A, B, and C plants are each in a region of area 4, and E is 3. The type D plants are in a region of area 1. Each garden plot is a square and so has 4 sides. Oh, true. A plot is, but a region. Okay. The perimeter of a region is the number of sides of garden plots in the region that do not touch another garden plot in the same region. The type A and C plants are each in a region with perimeter 10. The type B and E plants are each in a region with perimeter 8. The lone D plot, 4. Visually indicating the sides of the plots. Okay. Plants of the same type can appear in multiple separate regions, and regions can even appear within other regions. For example, the above map contains 5 regions. One containing all of the O garden plots, and the other 4 containing a single X plot. Yeah, that makes sense. Okay. I mean, it does make sense. Okay. The 4 X regions each have an area 1, because area is the number of garden plots. And perimeter 4. The region containing 21 type O plants is more complicated. In addition to its outer edge contributing a perimeter of 20, its boundary within each X region contributes an additional 4 to its perimeter. For a total perimeter of 36. So the way I look at that is it's saying you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. How does it say it gets a perimeter of 20? Oh, right. Sorry, because you're going around it. Yeah, it took me a second. Okay. So 5, 5, 5, 5. So that's 20. And then you have 1, 2, 3, 4 around those X's. So that's 16. So you get 36. Okay. Due to modern business practices, the price of fence required for a region is found by multiplying that region's area by its perimeter. The total price of fencing all regions on a map is found by adding together the price of fence for every region on the map. In the first example, region A has price for... Anyway, the price of fence required for a region is found by multiplying that region's area by its perimeter. The total price of fencing all regions on a map is found by adding together the price of fence for each. So in the first example, region A has that, has that. So you multiply those up. Good, I got 2 examples I can do tests on. In the second example here, actually 3 tests. As price that, here's a larger example. Let's get our puzzle input. Oh my god. And look, gee, kind of like if you wait, I'm going to move back a little bit. I'll actually just do that. Does that look like something? Does that look like something? It looks like something to me. I can't tell what that looks like, but it looks like something to me. Okay, so save as. This is day 12 input. So, how are we going to do this? I think we read the map in, and then we just start going, I and J, and we look at the first element, and we say, is that element in our set of regions? So we keep a set of regions around, okay? If excuse me, if we have this point in a region, we stop for whatever reason, which of course the first one is going to be the start of a region. Okay. Now, if we don't, now we got to find out, well, this is at least a region in and of itself, but how far does it expand? And we can't just assume it's going to do like a plus up and down. Every time we find a new point, we have to say, okay, go all directions, assuming that it can. And by can it, what we mean by that is, does it go outside the bounds of the map, or does it hit a plot that isn't of the same type? Yeah. Because if it hits it's either gone outside the bounds of the map, it's gonna hit a plot that isn't of the same type, or you've already found it. So like, and the reason I'm getting into that is something like this. Like you start moving through here, and you realize, well, this is one. This this is one. So you have to keep exploring. You find one here. Yeah, I can't get my. Doesn't want to just do this one there. Well, we know that we can go like. Which ways can we go? Well, we know that we can go like this way. The thing is, we got to get it to stop. So, I think the way you get it to stop is by when you go out and you come back in, is that you're going to finally realize that either all directions either gets you outside the map, it's going to bring you to a point that you've already done, or or it's a different plot type. Now, once you have the regions, I believe it's pretty simple. So once you get the count of regions, well, no, it's not. The area is simple. That's just the count. But then the perimeter is tougher because now you have to take each side and say, well, what's around me? In this case, if you follow the map, that would be a that'd be a fence. Here you go off a fence. Here you're going to run into a different type. That's a fence. But if you run into the same type, that you do not put a fence. So this one's count is 3. This one, yep, there's a fence. Nope. We have the same in our region here. This one says, yep. Don't search. Just search for a minus sign. That one says nope. So actually, maybe it's not that bad. You just go through each region, you go back on the map, and you go in all 4 directions, and you say, if I go outside the bounds, or the plot in that direction is not the same as me, that's a count. That's a fence. And so that adds 1. So it's actually not going to be that hard. You just have to find the regions, and once you have the regions, you can get the area, and you can get the you can get the regions, you can get the area, and you can get the perimeter rather-ish okay. So let's do it. It's nice that we technically get 3 inputs. This one, and this one. So we got at least 3 tests with values that we know. And we can break it down even farther by saying, well, we should have seen this region with 4, 8, 9, 10, 11, 12. You see how that keeps tracing through? Oh, because I added 12. Okay. So let's add 12. It's been a while since I added something. Okay, let's go look at 10 because that's... Day 11 started breaking our pattern because we had to really... What are we getting the price? Our price is equal to input length, return price. Of course, it's not going to be that simple, is it? Okay. I knew I had a... So we know what our bounds is, okay? Public, sealed, record, plot. A plot is... What are they calling these? Char plant, int x, int y. So a plot as a particular plant at a particular location. A region is the regions No, oh my God, why? Why did you do that? No is equal to, I get it, it's a keyword, but whatever. So we want a region is a collection of points or plots. Like that. And so the regions are a new list of regions. Okay. I'm going to say for var x is equal to 0. Oh, you're not going to x plus plus for me? Come on. All right. So now we're going to start going through each point. And we're going to say, we want to find we want to see if this point is in any of the regions we currently have. So for our region, or I could say for each regions and regions. If this region contains actually var skip is equal to regions contains a region that contains cannot convert lambda expression to type list of plot. I know. So we get a region. You don't know what that is? Yeah, it's got to be. We can rename that to a region. There, that's going to read a little bit better. So we want to find any region that already contains this plot point. If not any region we got some more work to do. Okay, so now we have to actually move on. And this basically is going to give us a new region. Var plant, since we're going to need to grab this anyway. And we got these reversed. We want to say input at Y, X. Right, and then we want to say var line is equal to input at Y. Okay. And so the plant is the line at X. If we have a new region, plant X, Y, right? Oh, and then we say new plot. There we go. Okay. And actually we want to do that. What don't you like about this? Oh. There we go. Okay. So now we have a region with at least our point. And now we need to do something where we say basically go through a while loop until we can't anymore. Plots is going to be equal to a new list of plots. Because we're going to start with this. So we're going to be given a list of points to look at. And every time we go through the list, we need to look at each one and say, which ones do we keep looking at? And if there aren't any, if there aren't any, then we break out, right? Yeah, I do not want to simplify the name because these are not plot. These are not regions. These are just a list of things to... Oh, yes. You're not going to like that, are you? Yeah, because it's not in the context. Fine, we'll do our friend while true. So that's what we want to find. And then we want to say for each var plot in, yes. So now we're going to go through each plot and we're going to say before I forget. There. If new plots not count is equal to 0, we break. And so we come down to that. And then after that, we just take the regions and we get the areas, but then we also have to get the perimeters. So a little bit of work. Now, if we don't have any, we break. If we do, we need to say plots to analyze is equal to new plots. Left, up, right, down. If X is greater than 0, then we can look. No. So if X is greater than 0 and we can say line at X minus 1 is equal to the current plant that we have. Then what? We know that to the left of that plant, of that plot, is something we need to add to our region. So we want to say new region dot add a new plot. Well, it's going to be the same as our plant. We don't need to do that. At X minus 1 Y. Okay, so that adds it to the region. But now we also need to add it to new plots. So we want to say our new plot to analyze is equal to that. We put that in here. And we say new plots to analyze. New plot to analyze. So we put it, we find that to our left, we find that we have a a plot that's similar to ours. So we're going to make a new plot, including that. We're going to add it to our region. And we're going to say, well, we've got to go look at that one and go look in all directions. Okay. Now we go up. If Y is greater than 0 and input at Y minus 1, X is equal to a plant, Can't do that. Can't capture that. It would be nice to do that. I'm sure there's a way to do it. So now we say our new plot to analyze here is, it's going to be the same plant. It's X except Y minus 1. Yeah, that's good enough. Okay. Now we're going to go to the right. If X is less than max X minus 1, because if the lines are 5, X can get up to 4, so we got to be 3. And the line at X plus 1 is that. Now we can say X plus 1, put that new region in there, and then we do down. So now Y has to be less than max Y minus 1. And the input at Y plus 1 is that we can do Y plus 1. And then we say these are our plots to analyze. And we do that again. Always getting a new list as we go through this. So these check to make sure we don't go out and that the thing in that direction is of the same type that we are looking for. By the way, if you're new to the channel, please subscribe. I would greatly appreciate it. I'm trying to get to 1,000 subscribers. So if you haven't done that already, please do that. I'd greatly appreciate it. All right, so this makes sure that we have the restriction that we're not going out of the map and that the thing in that direction is the same kind of plant. And if it is, we add it to our region. We also say that's when we have to keep looking in that direction and see which way it goes. Okay. And so we might end up with one that basically says, oh, yeah, I forgot about that. A region is a distinct set different. What we want to say here is if we actually add it. So this also makes the check to say, hey, if we've already gone that direction and that's one that's already in our region, then we don't add it to our plots because this one's yeah, okay. So we can just copy pasta. Good thing I remembered that. All right, so now we have we have all the directions, which is good. Max Y, max X. And then so this should find all of the distinct regions. So a little bit convoluted, but we get there. Now we have all the regions. Go through each one and get the area and perimeter. Calculate the price and add it to the total price. So now we come back up here and we say, no, don't need that anymore. This is going to be 0. Okay. So now for var region and regions, we're going to say var area is just the region count. That's easy. our perimeter is a little bit harder because we have to for each of our plot and region. Okay. And so we're going to be adding the number of fences for each plot. But once we have that, we're going to say the price is the area times the perimeter. Right? If that's price of a fence required for regions following multiplying the area by its perimeter. Okay. So now what we need to do here is in each plot, we need to do we do left, up, down? Yes, we do the same thing. Left, up, down, right. Okay. And so what we want to do is we want to say, if we can go that direction, if the thing next to us in the map, not in a region, but in the map has, because we should have found it. If what's right next to us, if we can go that direction, if what's right next to us is the same plant type, it's in our region. We're going to have to go look at the map and look at it because it may be something next to us that isn't of the same plant type. Okay. So these aren't the same things, but we're just using this as a template. Okay, so if plot.x because we want to look to our left. If that equals 0, that's a perimeter. Or at the input of plot.y, x minus plot.x minus 1, if that equals our plot's plant, then we do perimeter plus plus. I think that's correct. Now we go up. So if we say, if for y, that means we're at the top. Or the input's minus 1, but at the same x, we do that. Now we go to the right. So if this is less than max x minus 1, or at the y, except we're going to go plus 1 here, and then down. So this has to be less than max y minus 1, and then plus x, and we do that. Okay, so that gets us all the perimeters. Except not quite. I don't think this is right. Does not equal. There. So let's check this. We go through all the regions. We get the area. The perimeter is we look at each plot in a region and we say, for example, left. If we're already at the leftmost one, or on the same line, but the plot left to us is not the same plant. That's a perimeter. Does this work? What's the answer? Of course not. There's no way this could work the first time. Come on, people. We actually want to test that. Yeah, let's copy 8 because we want to do that one simple trick. So let's comment out this. Except we can do part 1 small. So let's come back up here and let's get this one. And then for solution day 12, part 1. In the first example, the total price should be 140. Is that correct? Nope, it is not. Index is out the boundary. Yay. Line 10. What? We should get an array here. The max X should be... Oh, yeah. We have link 4. So the input, so we have 4 and 4. Yeah, I don't understand why. Ew. So we got to, how many regions did we get? 9. That don't sound right. We should have had 5. So something is already messed up. But let's at least look at this. What's... Plot of X is 3, max is 4. Oh. Yeah, that's... It has to be... It has to be equal to, in this case. Because we're saying if we're at 3, then we would do 1. Otherwise, we are less than that because there's no other value we could get there. So now at least we shouldn't get an index out of bounds area, but we probably... Yeah, not quite, because we're not getting the right number of regions. Well, let's have some fun with this one. Well, actually, let's see if we can glean anything from our regions. So the first one we get is a count of 2, and that is A and A. This is A and A. A. Yeah, it's not quite right. Not quite right. But that's okay. Let's do some debugging. So we're going to go through all of our, we get a line of A's. Okay. So we get a plant at 0, 0. That should be an A. Do any of the regions currently have a region that contains this point? And it shouldn't be. So now we make a new plot. Or we get the plot. We get the new region, which we should be adding down here, which we are. Great. So now we got to look at the plots analyze, which should just be 1. And we see which ones we should be analyzing. So we want to look left, but we can't. Okay, up, we can't. Right, we can. And we should find on this line that yes, we get a new plant or a new plot with the same plant at X1, okay? And now we add it to our region. Yay, we added it to it. And so we say new plots to analyze is that one. We look down from us. Why does it... I don't like this debugging experience. Why does it just skip? I do not want you to do that. It's like it just zooms past everything and gets into... So we know what we did right. Now y should be 0, which is less than that. And we look at the input for 1 at that, and does that equal the plant? Why did it... Oh, God. Why does it do that? This isn't so much, you know, the debugging experience, again, with this new system testing or testing thing is a little wonky. Okay, so we go down. And we want to look through all of our plots to analyze. This should stop this from skipping. I don't know why it's trying to skip over this. Which it doesn't equal fine. We should have 1, and the one that we want to do is the second one. So we shouldn't break. Plots to analyze is the new one. Yes. So now we don't know, except now we're going to look for 1, 0. Okay. Oh. Yeah, that's wrong. We don't want to look at the current plot that we're on, dummy. Oopsie. Oh well, it's a somewhat forgivable oopsie. Okay. Now what do we get? Still a failure. Too many. How many plots are we getting this time? Or regions, I should say. 6. So we get the A's. That's good. Get the B's. Except the C's are wrong. We don't get... okay. So I bet we... Okay. Hold on. So the C's are just 2 and then down. This is just the D. This is the right one. This is the one that actually I think... Except that's really wrong. It shouldn't even have 6. I don't even know why it has 6. And then these are the E's, those 0, 1, and 2. Okay, so the C thing is screwing it up. We have one that just has 2. And then we have this one that for some reason... 3, 2, 2, 2. 0, 1, 2, 3. 3, 2. I don't even know where it's coming up with 3, 2 there. Because X is 3, 2. Okay, so that's... It's thinking it's that one. And then for some reason, it's picking up that it thinks that is... Okay, I only want to do this now when I have a new plot. Or, yeah, when I think I need to, because that's when I'm going to start to run into the C's. Okay, so that's an A. That's a B. And now we got our C. And our C is at X2, Y1. That's this one. Let's zoom that in a little bit. Okay. So we go look at our plots to analyze, and we say, which ones do we have to analyze? This one is C at 2, 1. So what we want to find is 2, 2. We shouldn't find anything left, up, right. Down we should though, yes. Which we do. And we add it because that's a new plot to analyze. We don't break. Now we say what's a new What's the plots to analyze? Now we have 2, 2. Okay. Now left shouldn't give us anything. Up should, but we shouldn't be adding it because the new region already has what's above us. So we should go into this. We're going to say that the new plot to analyze is a C21. Do we add it though? We don't. Okay, which is good. If we look to the right and there shouldn't be anything, down there shouldn't be anything. So now we say we still have one to look at. Wait a minute. We should have had it to the right, right? Going to the right should have done it. Plot to analyze is that we look at our current line, we say it's the same plant. We should add to it. Add to the new region. I'm a little confused. Why did that not go that way? Okay, so we got new region. Plot. Okay, so here's the C. Now we're starting with the C's. Left. Why? Why does it do that? Oh God, this is so annoying. Okay, now we got our C's. So we're going to put in all of our breakpoints just to make sure. So now we have the plot to analyze, which is 2, 1. Left and up shouldn't do anything. Right, 0 and 0. Down should. Yes. So that should give us 2, 2. And it does. And so we add new plots to analyze. And the count is 1. Okay, so now we come back up here. And our plots to analyze is 1. Got 2, 2. Okay, so now we get new plots. This should be same thing, except we need to go to the right. Up, we'll find it, but we don't add it. Okay, so right, plots to analyze, this is 2, which is less than 4 minus 1, and the line at BBCD. Oh. Yeah, I always need to index into this. This is looking at the line itself. But that's, no, that... Oh, because this is a new point in the I'm stupid. Okay. So we always need to do this. We always need to say input plot to analyze y. Let's get rid of all the breakpoints. And now we need to say left and right, they're relative to that plot's point, not our current line. Okay, now what do we get? and we get a passing. So let's do medium. And what is medium? That was this. A little bit harder. This should have a total price of this. Is this wrong? Nope. Let's do large. This should be 1930. Is that wrong? Nope. Let's go big. Twelve. 12. Except we want to read it like this. Yes, and it's part 1. And we need input 12. What does this give? Well, it took a while. There, you copying it. Yay! Hey! Progress. Progress. All right, so let's say enter stash. Part 1 of day 12 is complete. Now it's going to kick our butt. Continue to part 2. Fortunately, the elves are trying to order so much fence that they qualify for a bulk discount. Under the bulk discount, instead of using the perimeter to calculate the price, you need to use the number of sides each region has. Each straight section of fence counts as a side, regardless of how long it is. Consider this example again. The region containing type A plants has 4 sides, as does each of the regions containing plants B, D, and E. However, the more complex region has 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. Yes, you're correct. Using the new method of calculating the per region price by multiplying the region's area by its number of sides, regions A and E, a price of 16, so the price goes down. So the smaller example was 140, now it's 80. The second one was 772, but now we're getting a bulk of 436. And we're also getting, here's a map that includes an E-shaped arrangement full of type E plants. E-shaped region. And this map has a larger example, so we're getting even more examples. Oh my God, I just realized. This map has a total price of this. It includes 2 regions full of type B plants, each with 4 sides, and a single region full of type A plants, with 4 sides on the outside and 8 more sides on the inside. Be especially careful when counting the fence around regions like the one full of type A plants. In particular, each section of fence has an inside and an outside, so the fence does not connect across the middle of the region. Right. I get why they give you that caution, because depending upon how you do your algorithm, if you're strictly going to look at and say, well, these two, I mean, I can kind of see why they're doing that. The elves would have used the Mobius Fencing Company instead, but the contract were too one-sided. You're so funny. The larger example from before now also has... So they're giving you more examples, which is good. So I think, you know, it's the same region. Except for each region, we now have to say if we would have a fence there, so this is all good, except now we need to calculate lines. And I think to do this, you basically say, if I'm looking to the left, I would put a fence there. But what I also need to do now is say, add it to a list of lines. And a list of lines basically says, okay, I need to find where to add this onto. If there's nothing added onto, then I make a new line. What I mean by adding onto it is I need to find a line that currently exists that has either the same X and a Y plus or minus a difference of what I have, or Y plus or minus a difference of X, because that means it connects to one of the endpoints. And if I have that, then I just add it to that line. If I don't, then I make a new line. So I could say var lines is equal to a new list of plots, but not really. It's a list of plots. Actually, a list of points. Because a line is a list of plots. So we could do the same thing up here. We could say using a line is equal to sort of this, but not really. It's a list of plots. Sibit, stop. This is part 1. Let's get part 2. Probably not the smart thing to do to get copy pasta, but hey, this works, okay? So now what we want to say is var lines is a new list of lines, okay? And now for each plot in our region, we first see if we're going to make it. If we do, it's a little different now. Now we have to say find me the line or don't. Var line is equal to lines single or default, right? Because what we're trying to find is a line that I could connect this thing to one side or the other. So what I want to find now is any P. These are L's. We're taking the L. I want to find a line where it has a plot where either the plot in the line, its x is equal to our plot's x, our plot x. So we're going to have four conditions. We're going to say either the we're going to find a line that has a plot where its x is equal to that and the plot's y is either above or below it. We don't care about max x and max y right now because we would never have put a point below that, I don't think. So we can say it's the same x. Let's go left. Minus 1, and the py is equal to the plot's y. So what this is saying here is we're finding a point in the line that is strictly to the left of it. But we got to be careful here because this would also work to be adding it if it was, you know, if it had other ones, right? Because a plot can have at most 3. Unless it's a single, and then it would have 4. So at most 4. Yeah, we can do this. Okay, I'm maybe overthinking this. So I want to look at its leftmost side. So I want to look above me and below me. Or y minus 1. God, stop it. If line is not null, then that means we can just add it to the line. And a plot can be part of many lines. It can be part of 3. It can be part of 4. Right? So the line's on null, we say line.add plot. Okay. Shut up. Else. lines.add a new line with the plot being part of it. No. Come on. There. All right. So that does the left. So we're looking left, and then we have to see above and below us. Up, we want to look to the left and right of us. So we want to look to the left and the right of us, but keeping the same Y. Right is the same thing as a left in this case, I think. Because up and below, yeah. And then up and down is the same. And so here now we just say is the lines.count. And we get our answer. So this is small, part 2. It's saying this is 80. Part 2 small. Run part 2. How far are we off? Sequence contains more than one matching element. Guess I didn't expect that. Oh, yeah, I'm being stupid. It's not a single, it's an any. Wait. It's not an any, though. Sorry, just filling the old coffee here. By the way, make that plea again if request. If you're new to the channel and haven't subscribed, please subscribe. I would greatly appreciate it. Okay, so it's not that. Obviously, we're getting more than what I thought I would. Okay, I can kind of see where this would fail because this is, if you're going across like the A's here, it's not quite the same thing, you know, getting for this one, we would see that we need a line this is, I think, where we need to add a direction. Like, or side, left side, right side, upside or downside. think that might be... Or that. That works too. Except the line also needs a side. So it's not just a plot, it's also a side. Ah! Oh, is this that stupid item? Yeah. Plot. So do you have any that can be adjacent to it where P dot side is equal to side dot left and it's one of these? You need now to say side dot left. There. Of course, I got to change the other code. But I think that's what we're looking for. We want to have a single line where the fence is on the left of the plot and it's one of these adjacent ones. Oh, you're not going to be nice to me? Except now it's top. And that. If we don't have it, it's going to be a plot side up top. That's what I meant. It's totally giving me completely wrong information. Right. So now we want the P to be to the right. You are stupid today. Okay, so we get that. Except here, no, not left. The right side. Not top, the right side. Oh my God, is it failing? And in this case, bottom. Hey, you got that right. No, bottom. Okay. Now I think that passes. Okay. Whew. Part 2, E shape. This one says that. That passes. Two B's and A. Two B's in A. Wait a minute. 236, right? Wait, whoa, 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 whoa. This example, 80. We're on part 2. The E shape, 236. Okay, I got that right. The second example, full of X and O plans. Okay, that's the one I missed. So let's do part 2 here. Medium, make sure that's part 2. And they're saying that should now be 436. And that is, we got the E shape right. And now we're saying this map should be 368. And it is. And the large example, let's grab that one. Nope. Nope. Make it part 2. Part 2. That now should be this. And it is. Let's make sure we run all of them. They all pass. What happens when we do part 2? Oh, so we'll make that part 2. Call part 2. Just run it. Oh. I think I just realized one thing that could happen. Maybe. What happens if, like, you had a top and you had one over here and one over here? Like, it got split, like you went down this way and then you came back up and now it's over here. But that wouldn't be the plus or minus. You would realize that there isn't one that matches that. And therefore wouldn't return more than one. It's interesting. Yeah, this is fun because it's interesting that my that the way I'm doing this works for all the test cases, but not for the big ones. So what's interesting is, let's do this. Let's go to program and let's just let it fail. Okay. And let's see if we can kind of figure out why it might have failed. So this is our region. There's 120. How many regions do we actually? We find 584 regions. Okay. So we find a region. How many lines do we have at this point? 65. So this plots X. Well, the plot here is 87. It's at H, and it's 8768, which of course I will not remember. So it's line 68, which is actually 69. Okay, I can kind of... And we're looking at 87, which would actually be 88. So we see oh, I think I see what's the problem. It's possible, based on how the order has come into play, uh-huh. Uh-huh. I believe, I'll have to check this. But it's the order of which these are coming in. And so what I think is happening is that there's, sorry if you can't see this, but this is part of a line that has the side of left. And then down below, this is part of a line. And so this comes now in, these two are already created. What I need to do is not a singular default, but a select. And if I get distinctly 1, then I just simply add my plot to that line. If I get 2 or more, I guess just be general. What we want to do is then take the lines, those lines are returned, and basically make a new line out of those points, remove those 2 lines. So we make a new line based off those 2 existing, or the lines that we find existing, and the plot that we're currently on. And then we remove the lines that we currently find. So we're basically combining what we're looking for. I think that's what's happening here. So to confirm, what we're saying our plot is 68, 68, and 87. Now to go through all the lines here would be a little fun, because there's, like, how do you can't just look through that manually. That's what my gut is telling me, is that we need to get a select for all the lines. And then if we find more than one, we make a new line. Okay. So we say select. And then we say to list. To array, whatever. If line.count is equal to 0, wait. Oh, sorry. If line.count is greater than 1, and then we want a thing here to say else if line count is equal to 1, else now we do the add, because we didn't find any. If we only found one, then we take that line 0. Wait. Where? There. Okay. We don't want to do a select. We want to do a where. Just the wrong link. Wrong emphasis. The emphasis was on the wrong syllable. Okay, so now we have the count. If it's 1, we have 1 line. If we have more than 1, what we want to do is we want to say our new line is equal to a new line dot add range, and then yeah, okay, for each of our existing line in line. Actually, let's there's probably a little bit more efficient way to do this. New line add range of the existing line. Okay. We can also say new line, though, adding plot. Right? Well, plot plus side dot left. There. So we add in the point that we're at because we're making a new line. We're going to take all the existing lines and then we're going to say lines remove I wish it had a for reverse. We want to say for var existing line it is less than existing lines that count -1 is greater than or equal to 0 el minus minus. Huh? Oh. Equal to. Jeez. Brain failing. I've been doing this for almost 3 hours, so. Okay. No, wait a minute. Couldn't we just say lines that remove all? Remove range. No. Can I say or just remove? Yeah, that's what sucks about this. Okay, so we take the existing line that we have, we add it to the range. And then we say lines. Well, wait a minute, what? Sorry. Let me get back to. For each of our, yeah, we're iterating over existing lines, which came from this query. We can then just say lines.remove. Okay. So just to go through this again, if we find more than one line, we create a new line using the plot we're looking at. We take those lines that we found, add their contents to the new line, and then remove it from the existing lines collection. If we find exactly one, we just add it. Otherwise, we make a new line. One moment while I change all this logic. I know I could probably find... Oh. See, there is no up, there's a top. Because we're not changing the query per se, we're just changing... I mean, we are. And now all these need to be side rights. I mean, this thing I keep copying and pasting, that could be a shared thing. You know, you get your query and then you pass it into that, but... And we change this to existing lines. And we say where to list. And then we make that, except these are all bottoms. Okay, first of all, what does that do to our tests? I'm just making sure it actually runs them. They all pass. What about our... Damn it. Okay, well, our answer's too low. That's only the second one we've gotten wrong. There was another one. I don't know why I'm not showing it here, but there was another one that I got wrong. Well, damn it. Just gotta check something here. Well, at least we got a number this time. Unfortunately, it wasn't the number that I was looking for. And again, it's funny because the 3 or 5 test cases, they all work, but the larger data set doesn't. And we're getting too cheap of a price, which makes me kind of wonder. Oh. What happens if we have a piece that has nothing? Hold on, I'll be right back. I just had to check quick. And then my son was getting my older son was getting my younger son from school. I think that's something I'm missing from these. No, this should have picked it up. This one. This one doesn't have any lines. This one doesn't have any perimeters. So I don't know how that's getting the right price. Same with this one. That's an interior. What I'm saying is interiors, I'm not handling correctly. What I'm saying is that if there's a I think, go through this again. If the plot is at 0, that means you'd have one on the left. Or the plot to the left of it is not the same kind. Okay, so then something like that should never generate a new line at all, because it would never even find in any direction a plant that would be different. What this is saying for left is I need to find a line where there's any plot in there where the side is to the left, it's on the same x coordinate, but it's either above or below me. And it's either above or below me. I mean, I guess I could simplify this a little bit and say it's either that or that. There, okay. I was like, why is that not? That's simplifying it a little bit, but I'm basically saying the side to the left, and it needs to be on the same X, and it's either above or below me. If I find more than one, I combine them into my new line, removing the lines that I had previously found. If there's only one, I just add myself to it. If I didn't find any, that means I'm the first one making the line. There. I'm just trying to clean these up a little bit so that they're all the same. The up is saying above me, there should not be a plant. Wait, what did I just do? Okay. And then this one. This is the Y. Okay, I think I might stop here because I'm almost going on 3 hours, and it is not obvious to me what I am doing wrong. Obviously, I'm doing something wrong because this is giving the wrong value, 936,593. Yeah, I'm too low. And I'm getting to the point where I need to walk away, let the brain think, and get back to this later. I may do this tonight. I may come and do a stream tonight, but I think for now it's a good stopping point. I don't know what the solution is. Nothing's really coming as obvious to go, what would the solution be? So let's just pause and let my brain think on it. And I'll come back hopefully later with some possible solutions. But for now, I'm going to stop. So if you're watching either now or you watch this in the future, either way, thank you for watching. Please subscribe to the channel if you haven't already. As I've stated, I'm trying to get to that magical 1,000 subscriber mark. So please subscribe if you haven't done that already. I will maybe stream tonight. Otherwise, I will do some streaming this weekend as well to make some more progress on this. I only have 2 more days of vacation, and I've got a lot of problems to solve. And I would like to solve as many as I can before I have to start getting back to work, because I have things that are going to kick in. Like I got a conference in March that I need to get some material together for. So I need to work on that. So I want to try to get as far as I can in Random.Code this year and not leave too much hanging that I got to do on other streams. And I do want to get back to gaming too. So I might start doing some gaming streams in between. We'll see. But I will definitely do some streams from either tonight through Sunday. And we'll see how far I get. So thank you for watching. Take care.